Hey folks, welcome to this episode on percent composition of hydrates. Now, in this particular example, we have a very basic percent composition question that relates to hydrates. You can watch some other videos that go into some more complex versions. Let's start with this one here, where it asks us about Epsom salts. So if you don't know about Epsom salts are that salt that you can buy from a pharmacy that you can use in your bath water to help soothe muscles. A lot of people don't actually know that it also can be used as a soil additive to help improve the blooms of flowers and of other kind of green shrubs. So you can put that on the kind of root base, and it helps with that bloom. So let's take a look at this Epsom salt, which is magnesium sulfate heptahydrate. So first of all, let's create the formula for this. Okay. So remember magnesium sulfate. You might spell sulfate a little bit differently. That's all right. Magnesium is 2 plus, sulfate is SO4 2 minus. And if we cross and reduce, we will get MgSO4, and hepta means 7. So we have 7H2O. So there is our equation. Now, we could do a percent composition right here, right? And this is what we're going to do. But this question has a little bit of added complexity because it's giving you an actual sample size of the Epsom salt. So it says if you added 20.73 grams of these hydrated salts, so the one that has the water attached to it, into your bath water, calculate the percent by mass that is made up of water. Okay, shouldn't be a question mark. It should just be a statement. Okay, so let's take a look at this. Now, to do this, we have to do our basic percent composition of this hydrate. All right, so we're going to start there. Now, if you're saying, I know how to do a percent composition, the first thing that we do is we separate our elements and then we find their masses, we divide by the molar mass. It's very, very similar, but here we are not looking for the individual atoms. We're looking for the different components of a hydrate. So what are our different components of a hydrate? Our first component is the ionic salt, and our second component is the water. So what we're going to do is we're going to split up these components and find their individual percentages rather than the individual elements. Now, this is going to come back to us when we look at our empirical formulas of hydrates. So let's split up these individual components. So the first component is the ionic salt, which is magnesium sulfate, and the second one is water. Now, let's take a look at these. The first thing that we need to do is we need to figure out the molar mass of magnesium sulfate. So remember that the molar mass of a compound is essentially just, in this case, magnesium plus sulfur plus 4 times oxygen. And if we do that, our molar mass will be 120.37 grams per mole. Now, for water, we do the same thing, and we're going to get 18.02 grams per mole. Next step is that we multiply by how many we have of each. Now, there's no coefficient in front of magnesium, and when that's the case, that means that it's a 1. So I'm going to take this 1, multiply there, and I have 7 waters. So this is just going to be the same number, 120.37 grams per mole. And this, however, is going to be 126.14 grams per mole. Alrighty, so this is the total masses or the total mass of all the different components that we have here. What we're going to do is we're going to figure out the total mass of our hydrate, right? So if we have magnesium, when we have 1 of them, and we have 7 waters, if we add these together, we will get the total mass of this hydrate. And in this particular case, this will be 246.51 grams per mole. So that's the total mass of the MgSO4.7H2O. Okay, now if we want to figure out the percent composition of each component, we need to take their individual masses and divide by the total. So that's what we're going to do. We're going to divide by that total, 246.51 grams per mole, and we're going to do the same thing over here. Notice that grams per mole are dividing by grams per mole, so these units are going to cancel out. We'll be left with the unit in this number, which is exactly what we want to get a percentage. And so if we do this calculation through, here we will get 0.488296621, and here we'll get 0.511703379. All right, now we just have to convert these into a percentage by multiplying by 100. Now we're going to leave these at two decimal places, I should say. to get us to allow us to calculate to 100 a little bit easier. And so if I round this off, I'm going to get 48.83. I'm going to round that portion over here up to 3 there. And again, if I want 2 decimal places, I'm going to have to round that portion, so round it down, and I'll have 51.17%. Now, quick calculation, quick check, this does equal to 100%, so I am good there. Now, what this tells us is that 51% of the total mass of this hydrate, so 51% of that total mass is made up of water, and 48.83% is made up of the magnesium sulfate. Now, going back to the question, it's asking us that if we had a sample of 20.73 grams of these hydrated salts, okay, what is the total mass that is of that made up of water? So all we can do is, we already know that 51% of any kind of sample is going to be made up of water. We can just apply to that 20.73 grams. So we have 20.73 grams of our hydrate, and we know that 51% of it, or 0.5117, is going to be made up of water. If I multiply this through, my grams can't cancel out because it's not multiplying by anything else. So in this particular case, I will get 10.607611105 grams. Now, note that even though I wrote this here, this value right over there, I actually multiplied by the entire value here. So I rounded off over here thinking that this is going to be my final answer, but really my final answer is going to be the one that I'm working with. So even though I wrote this down, I'm actually calculating with this entire value here and then rounding out at the end. So if I look at this and I look at my original value, this is a significant figure. This is a significant figure. Now this 0, because it's sandwiched between 2 significant figures, is also going to be significant. I have 4 significant figures, so my final value, my final answer, I should say, is going to be 4 significant figures. So that means I need to round this, and I'm going to round that up to a 1. So my final answer is going to be 10.61 grams. So of my 20.73 grams of my entire magnesium sulfate heptahydrate, 10.61 grams of that is made up of water, because any sample of that magnesium sulfate heptahydrate is going to be made out of 51.17% of water. Hopefully that helped you. Thanks very much for watching. Please watch the other suggested videos or any other videos that might help you in the playlist. As always, please like and subscribe to this video to get this video out to other people that also might need help in these calculations. Thanks again for watching, and see you on the next one.